Hello everybody, I'm Adam. In this problem, for the given parametric equations, which we have as x equal to 3 cosine theta and y equal to 2 times sine squared of theta, where theta is between 0 and pi, we're going to try and sketch and describe the orientation of the graph of these parametric equations. Now there's two ways to do this. Taking a look over here, we can simply, with values of theta, plot points x and y and use that to sketch out the graph. But it would also be a little more informative if you could find the rectangular form of the equation, because then you know what the equation exactly is supposed to look like. So that's how we're going to start. So we're going to start by trying to find the rectangular form of the equation. And finding the rectangular form of the equation, we're going to eliminate our parameters, theta. And how we do that when we have trigonometric functions as our parametric equations is we try to make use of some identity. So we see that we have cosine and sine, namely also sine squared. So that kind of indicates that we know we have one identity that, say, sine squared theta plus, say, cosine squared theta is equal to 1. Now, how can we make use of that? Well, simply taking a look here, we're going to, let's first try and solve each of these equations for the trig function part. So with x equal to 3 cosine theta, if we divide both sides by 3, that implies, let's say, x over 3 is equal to cosine theta. And for y equal to 2 sine squared theta, well, if we divide both sides by 2, that tells us that if we do that, we have y over 2 equal to sine squared theta. Now we can plug both of these into our identity to get an equation in terms of x and y. So doing that, so we have sine squared is equal to y over 2. So we'll have y over 2 in for sine squared plus cosine squared. Well, cosine is x over 3. So x over 3 quantity squared. And that's equal to 1. So there we have it. Now we see we're going to have a square on the x and a first power term on the y. So it looks like we have a parabola. So we'll just go ahead and clean this up just a little bit. So we're going to have, say, y over 2 is equal to 1, and we'll subtract our x over 3 squared term. So we have 1 minus, which would be x squared over 9, and say multiplying through both sides by 2. Well, that's going to leave us finally with y is equal to, multiplying through with 2, 2 minus, say, let's write it as, say, 2/9 x squared. So, right, there we have the equation of a parabola. Now, if we didn't have a restriction on theta, right, if theta could range through any values, we could probably just go ahead and try and sketch the graph of this as is. But since we have a restriction, we're going to go back and also plot some points. But it gives us a good bearing on what we know the graph is supposed to look like. So theta, ranging between, say, 0 and pi, well, let's go ahead and start with, say, theta equal to 0 and see what the values of x and y would be. So when theta is equal to 0, we know cosine of 0 is equal to 1. So x is 3 times 1, or 3, and y is equal to 2 times sine squared of 0. Well, sine squared of 0 is 0, so 2 times 0 squared is equal to 0. And, well, we'll just go ahead and pick some easier values, and we'll fill things in if we need to. Let's say the next theta value is, say, pi over 2. Well, cosine at pi over 2 we know is 0, so x is 3 times 0, or 0, and y, 2 times sine squared at pi over 2. Sine at pi over 2 is 1, so 2 times 1 squared, which is 2. And again, theta is ending at pi, so we'll take theta to be equal to pi. And cosine at pi is negative 1, so x is 3 times negative 1, or negative 3. And sine at pi is 0, so y is 2 times 0 squared, which is 0. Okay, so let's plot these points and see what we have. So our first point is going to be x is 3, y is 0. Our next point is going to be x is 0, y is 2. And the last point we have, x is negative 3, y is 0. So right over here. Okay. Now, normally we might plot a few more points to kind of fill in the graph rather than just connecting the dots. But since we've already found the rectangular equation, and we know this is a parabola, we can kind of see the vertex of the parabola shaping here. So I think we're safe enough to just go ahead and with kind of the best curved line we can, connect our dots. All right? So there's the sketch of the equation. Now what we want is indicate the orientation. So following theta increasing, so theta going from 0 to pi over 2, we went from our point here to our point here. So we're moving that way. And then from pi over 2 to pi, we went from our point here down here. So our orientation is going this way. So there's the sketch of our graph with orientation. Thank you very much.